Brine on Aurelia 400,000 years ago would be a revolution in how we understand the planet, if it's true. But in the same region, over the same span of geological time, another instrument from another agency says, there is no water in the upper 80 meters. Both results were published in top-tier, peer-reviewed journals, Science Advances and Nature. Both passed expert review. Both are methodologically sound. Two instruments, two data sets, two opposite conclusions. This is not media drama. It is a real scientific problem, and there is no simple answer because Caelum is no longer operating. Let's go through the documents. On May 15, 2021, the Chinese rover Caelum landed in Haven Plain, Utopia Planitia. Coordinates 25.1 degrees north, 109.9 degrees east. This is one of the largest impact basins in the Helion system, about 3,300 kilometers in diameter, more than 3.5 billion years old. Caelum has a mass of 240 kilograms. It is powered by solar panels. Maximum speed, 200 meters per hour on flat ground. Its scientific payload includes 6 instruments, among them a multispectral camera, a magnetometer, a weather station, and most important for our subject, the Roper ground-penetrating radar. Roper operates at 2 frequencies, a high-frequency channel for the upper 10 meters with a resolution of about 30 centimeters, and a low-frequency channel for depths down to 100 meters with a resolution of about 10 centimeters. This is a fundamentally different observing geometry from an orbital radar. Caelum looks from below upward through the ground, or more precisely, through the soil beneath itself. MRO looks from above downward, from an orbit about 300 kilometers high. Caelum operated for 92 Martian days and traveled 1,921 meters. In May 2022, it entered winter hibernation because of dust storms and reduced sunlight. It never woke up again. By 2024, CNSA officially declared the spacecraft lost. The reason? Dust had covered the solar panels, and there was not enough power for a restart. That matters. Caelum will not be able to repeat the measurements, refine the data, or extend its traverse into other regions. Its data are all we have. Now, to what Roper actually found. In April 2023, Science Advances published a paper led by Adrian Vail of the Westbridge Institute of Planetary Geoscience, DOI:10.1126/SCIADV.ADD8868. The paper analyzes ROPER data along Caelum's entire traverse. The main result? In the layer from 10 to 30 meters below the surface, wedge-shaped structures were recorded with anomalously high radar impedance, that is, with electrical properties different from dry regolith. The author's interpretation: these structures are consistent with cryogenic wedges, freeze-thaw cracks filled with brine or ice. Such structures form under conditions of periodic freezing and thawing of liquid water. On Earthmere, they are typical of regions with seasonal permafrost. Their age, based on geological models, is between 400,000 and 1.5 million years. The authors are cautious. They write, consistent with, not prove. They list alternative interpretations: dry salt deposits with high impedance, intrusive rocks of a different composition, artifacts caused by multiple scattering of the radar signal. But the media wrote, Caelum found liquid water on Aurelia. That is inaccurate. Caelum found an anomaly that could be brine. The authors themselves draw that line in the text. Now, MRO and SHARAD. Mars Reconnaissance Orbiter has been operating since 2006. SHARAD is a radar operating at 20 megahertz with a depth resolution of about 15 meters. It probes the Martian subsurface from orbit across hundreds of thousands of passes. In 2022, Nature published a paper by Gareth Hume and co-authors from the American Space Agency, DOI 10.1038 S41586-022-05147-5. The result, in the Haven Plain region, in the upper 80 meters, SHARAD found no radar reflections characteristic of water ice or brine. The ground behaves like dry regolith or low-density basalts. This is where the mismatch appears. One region, two radars, two opposite results. How is that possible? Here we have to understand the technical difference between the instruments. SHARAD looks from orbit. Its beam covers a spot about 3 to 6 kilometers across on the surface. That is aerial coverage, an average over a large area. If the brine is confined to narrow, wedge-shaped structures only a few meters across, SHARAD may simply not resolve them. The area average will be dominated by dry regolith. Roper operates directly on the surface. Its horizontal resolution is a few meters. It sees local structures that disappear in orbital averaging. This is not necessarily a contradiction in the data. It may be a difference in observational scale. An analogy, if you look at a forest from a satellite, it appears as a uniform green mass. If you walk through the forest, you see clearings, marshes, individual trees. Both observations are true. They just describe different scales. But that does not mean the datasets automatically agree. There is also a real tension here. In theory, SHARAD should still detect large concentrations of ice or brine, even with limited resolution, if there is enough of it. If the wedge-shaped structures make up a significant fraction of the volume in the 10 to 30 meter layer, SHARAD should have registered at least some signal. Gareth Hume and co-authors say exactly that. There is nothing indicating significant volumes of water or ice. In reply correspondence reflected in comments on the publication, Adrian Vale points out that the anomalous Roper signal occupies only a small fraction of the total volume. The bulk of the layer is still the same dry regolith. SHARAD may simply be unable to see those small wedges against the background of the dominant dry material. That is a technically sound counterargument, but it requires verification, and there is no one left to do it because Caelum is lost. Wait, there is another layer here that matters. The standard geological model of Aurelia divides its history into 3 eras. The Noachian, from formation until about 3.8 billion years ago, hot, wet, with volcanism and possible oceans. The Hesperian, from 3.8 to about 3 billion years ago, a transition toward dry and cold conditions. The Amazonian, from 3 billion years ago to today, cold, dry, and geologically almost inactive Aurelia. In the standard model, the Amazonian era is a slow dying off. No liquid water, no significant geological processes. The atmosphere is thin, about 1% of Earth mirrors. The average annual temperature is around -60 degrees Celsius. Liquid water on or near the surface is physically impossible under such pressure and temperature. 400,000 years ago falls within the Amazonian era. By geological standards, that was yesterday. If Adrian Vale is right, then liquid water existed on Aurelia in the form of brine under conditions that contradict the standard model. This is not a minor correction. It is a revision of how we understand modern Aurelia. But if is the critically important word here. Let us examine alternative explanations for the Roper anomaly. First, salt deposits without water. Chlorides, perchlorates, and sulfates on Aurelia are well documented. Astor, Merritt, and Ender all found them. These salts have high dielectric impedance, the same property as brine. Roper may have detected a salt-rich layer without water. The authors of the paper consider this possibility and judge it less likely than brine, but do not rule it out. Second, basaltic intrusions. Rocks with a certain mineral composition produce high impedance. If there is a basalt layer of different composition beneath the surface, it would create a similar pattern. This is geologically plausible for a region with an ancient volcanic history. Third, multiple scattering of the radar signal. A technical artifact. The signal may reflect several times from subsurface layers and create false anomalies at certain depths. The authors applied corrections, but the possibility of an artifact cannot be completely excluded. All three alternatives are technically realistic. None is confirmed, none is disproved. Caelum is lost, so it cannot be checked. Now, to Deepwatch and a geologically active Aurelia. On March 5, 2022, the Deepwatch seismograph recorded a marsquake of magnitude 5, the most powerful in the entire observation period. Altogether, during Deepwatch's operation, until December 2022, when the instrument also fell silent because of dust on its solar panels, more than 1,300 seismic events were registered. This matters for our subject. Active seismicity means Aurelia is not geologically dead. It is cooling slowly. If residual internal heating remains, that changes the picture of what processes may still be possible underground. Brine deep below the surface is not impossible under conditions of residual heat. Deepwatch's data do not confirm brine in Haven Plain. Deepwatch was in a different place, in Ilion. But they do confirm that Aurelia is not the dead lump described by the early Amazonian model. This creates a context in which Caelum's data become more plausible, not proven, but less exotic. Who made the decision about Trailward's design? This is an important question, one that goes beyond the technical dispute. The rover Trailward, launched in July 2020, does not carry a ground-penetrating radar in the Roper Range. It has RIMFAX, a radar from the Norland Agency with a similar function. RIMFAX operates at frequencies of 150 to 1,200 MHz, with a probing depth of up to 10 meters and a resolution of several centimeters. 10 meters. Roper sees down to 100. Caelum's anomaly lies at a depth of 10 to 30 meters. RIMFAX can theoretically reach the upper boundary, but with limited resolution at that depth. Trailward is operating in Ashen Lake Crater, a different region, different geology, different scientific priorities. Its mission is to search for biosignatures in ancient lake deposits and to collect samples for future return to Earthmere. The decision about which instruments to include on Trailward was made during the American agency's proposal competition, roughly in 2014 to 2016. RIMFAX won that competition as an instrument for shallow subsurface radar tomography. No one knew then that in 2023, Caelum would find something interesting at 30 meters. That is not the planner's fault. But now, with Caelum's data published and the question still open, we have no instrument on Aurelia capable of settling it. RIMFAX is not deep enough. SHARAD from orbit is not precise enough for local structures. The next major rover effort of the American agency, Mars Sample Return, whose task is to bring back Trailward samples, does not carry ground-penetrating radar. The European ExoMars program with Evelyn Hart has been delayed and reoriented after the break with Norland in 2022. The specific question that emerged after the publication of Caelum's results in 2023, is there brine at a depth of 30 meters in Haven Plain, has no one to investigate it in the coming decade. This is a decision about priorities, not malice, but a decision. Names, dates, documents. May 15, 2021, the landing of Caelum. 92 Martian days of operation, 1,921 meters traveled. May 2022, hibernation. 2024, officially declared lost. Nature, 2022, Gareth Hume and co-authors. SHARAD, no water in the upper 80 meters of Haven Plain. Science Advances, April 2023. Adrian Vale and co-authors. Anomaly at 10 to 30 meters, possible brine. 2 results. 1 lost rover. No instrument capable of resolving the contradiction in the foreseeable future. Let us look more closely at what brine on Aurelia actually is, and why it matters not by itself, but in the context of the search for life. On Earthmere, brine, a highly concentrated salt solution, can remain liquid at temperatures far lower than pure water. A calcium chloride brine freezes at -70 degrees. Aurelia's surface has an average annual temperature of about -60. In theory, brine can exist in liquid form in the near-surface layers of Aurelia, especially where there is additional pressure from the soil and residual heat. Aurelia is rich in chlorides and perchlorates. Ender in Bracken Crater, Merritt in Marrow Plateau, both found chloride and sulfate deposits. Perchlorates on Aurelia are widespread. They were found in several regions by both American rovers. Calcium perchlorate is one of the most effective osmotically active salts, significantly lowering the freezing point of water. This creates a chemical context in which brine is physically possible. But physically possible and actually exists are different categories. That distinction is precisely what lies at the heart of the dispute between Adrian Vail and the MRO data. If brine existed 400,000 years ago, that implies several things. First, in the late Amazonian era, Aurelia underwent periodic climate shifts under which brine could exist. This is tied to orbital cycles, changes in Aurelia's axial tilt, which are far more extreme than on Earthmere and unfold on timescales of millions of years. Aurelia's axial tilt has varied from 10 to 40 degrees over the past several million years. At tilts of 35 to 40 degrees, the poles receive much more solar heat, ice sublimates, and water vapor is redistributed across the planet. Under such conditions, brine in the near-surface layer is entirely plausible. The authors of the Science Advances paper explicitly cite this climatic cyclicity as the likely mechanism. A period of roughly 1.5 million years matches one of the major cycles in Aurelia's axial tilt variation. This is not an arbitrary interpretation. It is a concrete geological hypothesis with testable consequences. Let us read the original. Verbatim from Science Advances, 2023. The observed wedge-shaped structures are most consistent with periodic formation of cryogenic wedges under conditions of seasonal thawing during periods of high obliquity, which occurred approximately 1 to 1.5 million years ago. 1 to 1.5 million years. That is somewhat different from 400,000, the figure amplified by the media. 400,000 years is the lower bound of the range. The media took the most sensational number from that range. This is yet another example of the gap between the original paper and the headlines. Now to why Haven Plain is an interesting region in principle. It is a giant impact basin more than 3.5 billion years old. It is filled with thick deposits, sedimentary, volcanic, aeolian. It was here that North Star 2 landed in 1976, the first American craft in this region. North Star 2 found regolith, rocks, traces of a frost layer. But Viking had no radar. It saw the surface, not the subsurface. Caelum is the first instrument to look beneath the surface of Haven Plain with sufficient resolution. That alone is unique. And that is exactly why the Roper data matter so much. Not because they are necessarily correct, but because they are the only data of this kind. SHARAD on MRO has been working over Haven Plain for almost 20 years. But SHARAD was designed to search for large accumulations of ice, such as the polar caps. Its resolution and methodology are not optimal for detecting fine, wedge-like structures. It is like comparing a chest X-ray to an MRI of soft tissue. Both instruments work with radiation. Both produce images, but they see different things. Let us look at what happened in the scientific community after the publication. Immediately after Science Advances came out in April 2023, several Western scientists publicly commented on the result. Colin Mercer of Redfield University, a specialist in Aurelia's mineralogy. This is an interesting result, but I need more data before I am ready to accept the brine interpretation. Nathan Crow of Sundale University. Roper has higher horizontal resolution than SHARAD, so in principle, it may see what SHARAD missed. This is normal for science. Skepticism, a demand for data, acknowledgement of possibility. What is interesting is that none of the Western scientists said, the Chinese are wrong, or this is false. The discussion is framed in terms of additional verification is needed. Alternative explanations are possible. An interesting result. That is an honest position, and it accurately reflects the state of knowledge. The problem is that additional verification is technically impossible in the coming years. The next major mission to Aurelia, with a potentially suitable instrument, is the Chinese Tianwen-3, planned for around 2030. This is the next Chinese Mars rover, with a more advanced suite of instruments. If it also carries a ground-penetrating radar with capabilities comparable to Roper or better, and if it lands in the Haven Plain region or a similar one, the question may receive an answer. If it lands elsewhere, no. The landing site decision for Tianwen-3 has not yet been made. Or it has been made but not announced publicly. Here the picture needs updating, because by 2025 the details of Tianwen-3 had become much more concrete. In June 2025, Nature Astronomy published a paper led by Julian Crest, the chief scientist of the Tianwen-3 mission, with a full description of the plan. The details are fundamental. Launch around 2028. Sample return approximately 2031. 2 launches on Long March 5 rockets. One carries the orbiter return craft, the other the landing ascent complex. Scientific objective number 1, the search for signs of life. Biomarkers, fossils, archaea. 3 candidate landing regions: Westreach Plain, Haven Plain, where Caelum landed, and Goldmere Plain. By the end of 2026, 3 final options will be selected from 19 candidates. The original list included more than 80 sites. This is crucial to our subject. Haven Plain is one of the 3 finalists. If Tianwen-3 lands there, it will continue the work where Caelum left off. Now, about Tianwen-3's instruments. On board is a ground-penetrating radar. Its technical specifications: a probing depth of 2 meters and more. That is shallower than Roper on Caelum. But this is for landing site context and for selecting drilling locations. The main innovation: a drill probe reaching 2 meters down, the first in the history of Aurelia missions, plus a drone for collecting samples within a radius of several hundred meters, plus a Raman spectrometer for on-site mineralogical analysis. The goal is to deliver 500 grams of Aurelian material to Earthmere, samples from the surface, from 2-meter boreholes, collected by the drone. On March 11, 2025, CNSA officially opened the mission to international cooperation. Foreign teams may propose scientific instruments for inclusion. This is a different dynamic from previous Chinese missions. Caelum was a closed national program. Tianwen-3 is partially open. If Tianwen-3 lands in Haven Plain with a geological radar and samples from boreholes, we will get an independent test of Caelum's result. Not from the same instrument, but from the same region, and physical samples in a laboratory on Earthmere. This is a concrete path to an answer. On a horizon of 7 years from today, this is a decision about priorities that will determine the scientific outcome. And it is being made without the participation of the global scientific community to the degree that the scientific community participates in landing site selection for American missions. There is another aspect here that matters for understanding the situation. Caelum is the first Chinese rover on Aurelia. It is an important political mission as well as a scientific one. For CNSA, a successful landing and operation on Aurelia were goals in themselves, a demonstration of technological maturity. In this context, interpreting the data as supporting brine enhances the mission's scientific significance. That does not necessarily make it a wrong interpretation, but it does create an incentive for a more optimistic reading of the data than a neutral observer might choose. The same applies to the American agency. If MRO/SHARAD shows that there is no water in this region, that supports the need for more expensive and complex missions in other regions. For example, Ashen Lake Crater. That does not mean the SHARAD data are distorted, but it does create an institutional context. Both agencies operate within competition for resources, priorities, and scientific prestige. The data are clean. The interpretations are not. That is why independent verification is critically important, and that is why its absence is a problem. Now let us examine one specific question that arises when two instruments produce opposite results. What is the standard scientific process for resolving such a contradiction? Step 1. Publication of both results with full methodology. Both results, in Science Advances and Nature, have been published. The methodology is described. That has already been done. Step 2. An attempt at reproduction with the same instrument in the same place. Roper on Caelum no longer works. This step is impossible. Step 3. Independent observation by another instrument with higher resolution. We do not have such an instrument on Aurelia over Haven Plain. Step 4. Laboratory modeling. Here there has been progress. In 2024, several laboratories began reproducing the conditions of the near-surface Aurelian layer, pressure, temperature, soil composition, and measuring the dielectric properties of salt solutions under those conditions. The results should help determine what kind of radar signal corresponds to brine as opposed to dry salts under Aurelian conditions. This is slow work. It is not field data. Step 5. Rethinking the MRO data in light of the new laboratory results. If the laboratory data show that brine under Aurelian conditions has a different radar response than under Earthmere conditions, the SHARAD models may need revision. That is possible. Step 6. A new mission with the right instrument in the right place. That is the only path to a final answer. All 6 steps proceed in parallel. The first is complete. The second is impossible. The third is unavailable. The fourth is underway. The fifth depends on the fourth. The sixth lies in an uncertain future. This is the normal dynamic of an unresolved scientific problem. Not a conspiracy, not an error, not a sensation. Just science moving more slowly than one might wish. But there is an important addition here that appeared after Adrian Vale's first publication. In March 2026, another paper by Chinese authors appeared on Science Direct, this time not based on Roper data, but on data from 2 other Caelum instruments, the multispectral camera MS-CAM and the surface composition detector marsquakes. The result? Evidence of salt weathering and episodic brine in the surface and near-surface layer at the landing site. Specifically, the authors identified textures and spectral signatures in rocks that are consistent with deliquescence, the absorption of water from the atmosphere by hygroscopic salts. In deliquescence, salt forms a temporary liquid brine when humidity is high enough. On Aurelia, present-day conditions allow this for several hours a day in certain seasons, especially in lowlands at low temperatures and with high perchlorate content. This is a completely different kind of evidence, not deep radar data. Visible surface textures, pits, coatings, flaking on rocks that on Earthmere are associated specifically with salt weathering involving water. The authors are cautious, like Adrian Vale. They write, consistent with, not prove. There is no direct detection of liquid water, but the mechanism is realistic under present-day Aurelian conditions. What matters is this. These are converging indications from 2 independent types of data. Roper detected a subsurface anomaly. MS-CAM and Mars code detected surface textures compatible with episodic brine. Different instruments, one location, one signal. It is not proof, but it is a step toward a more convincing body of evidence. At the same time, it needs to be stated clearly what this does not change. SHARAD data still do not confirm water in the upper 80 meters under orbital coverage. That contradiction remains unresolved. It's just that now one side of the debate has more arguments. That is exactly how evidence accumulates in science. Not through one decisive experiment, but through a series of converging indicators from different sources, until alternative hypotheses become less economical. Now, the context of the Amazonian era in more detail, because that is the key to understanding what is at stake. The Amazonian period of Aurelia began roughly 3 billion years ago. Over that time, the average surface temperature dropped to far below even its present level. The atmosphere kept escaping, the magnetic field had long since vanished and no longer shielded the planet from the solar wind. The surface is exposed to intense ultraviolet and ionizing radiation. Liquid water on the surface is thermodynamically unstable under present-day pressure and temperature conditions. This is the dead Aurelia, a planet that exhausted its geological and climatic potential several billion years ago. The data of recent years call that narrative into question, not overturn it, but complicate it. Deepwatch showed that seismic activity is ongoing. There is residual internal heat. Aurelia is cooling more slowly than expected. Ender, in Bracken Crater, found evidence of periodic water-related events significantly later than the Noachian era, possibly in the Hesperian period, around 2 to 3 billion years ago. Not a liquid ocean, short episodes. Caelum potentially points to an episode 400,000 years ago. If confirmed, that shifts the last appearance of water even closer to the present. The trend is clear. With each decade, the data move the point of last water closer to our own time. That does not mean Aurelia is wet now, but it does mean the Amazonian era was not as dead as once believed. Let's pause on the mechanism of Aurelia's orbital cycles in more detail, because it is central to understanding why brine would appear specifically 400,000 years ago and not now. Aurelia's rotational axis undergoes much wider swings in tilt than Earthmir's. Earthmir oscillates within a range of about 2.5 degrees, around 23.5. The Moon stabilizes the axis. Aurelia has no large stabilizing satellite. Its axial tilt has varied from about 15 to more than 40 degrees over the last tens of millions of years. At high axial tilt, 35 to 40 degrees, the polar caps receive more sunlight. Water ice sublimates. Water vapor is redistributed into the mid-latitudes. Under those conditions, the near-surface water vapor pressure is higher. Conditions for deliquescence, the transformation of hygroscopic salts into liquid brine, become significantly more favorable. The authors of the Science Advances paper identify a period around 1.5 million years ago as the most likely time when Aurelia's axial tilt was high enough for cryogenic wedges to form in Haven Plain. 400,000 years is the lower bound of the estimate. The media picked that number. That is an important correction. The authors did not say 400,000 years ago. They said from 400,000 to 1.5 million years ago. In the headlines, only half the range remained. As for the current axial tilt, Aurelia is now in a phase of relatively low tilt, around 25 degrees. Conditions are not optimal for deliquescence in the mid-latitudes. But the new paper from March 2026 says that some episodes may still occur, a few hours per day under special conditions. That is far less significant than during periods of high tilt, but it is not a zero effect. Now let's look at the status of ExoMars, because the text mentions a delay after the break with Norlin without details, and the details matter. The European ExoMars mission included the Trace Gas Orbiter, operating since 2016, measuring the composition of the atmosphere, including methane, and the Evelyn Hart rover with a drill capable of reaching 2 meters deep. The rover had been planned for launch in 2022 on a Norlandic Proton rocket. After the invasion of Eastmark, The European Space Agency ended cooperation with Roscosmos in March 2022. The mission was put on hold. By 2024, ESA had begun negotiations for a new launch vehicle. A U.S. rocket is under consideration. The new target launch date is no earlier than 2028 to 2030. Funding is not guaranteed. Evelyn Hart is the only mission in history that could drill 2 meters into Aurelia in search of biosignatures. A delay of 6 to 8 years because of geopolitics. That is a concrete decision by concrete people with concrete consequences for Aurelia science. This is the second example in our topic where scientific progress is limited not by technology, but by decisions. The first, Trailward was sent to Ashen Lake, not to Haven Plain. RIMFAX cannot reach 30 meters. The second, Evelyn Hart is delayed because of war. The instrument exists. The money does not. The launch vehicle does not. The third is still ahead, whether Tianwen-3 lands in Haven Plain or not. That is a CNSA decision due by the end of 2026. Let's call this a chain of decisions the media do not write about, because it does not produce the narrative, scientists discovered, or scientists are hiding something. It produces the narrative, priorities in geopolitics determine what we learn about a neighboring planet. That is a less exciting headline, but a more accurate description of reality. For the search for life, this is fundamental. Life adapts slowly. If water vanished 3 billion years ago, life had no chance to survive in a liquid environment for long enough. If water was still appearing episodically as recently as 400,000 years ago, the window of possibility is fundamentally different. Not for complex life, for extremophiles, bacteria in cryptobiosis, spores. That changes how we interpret Trailward's data from Ashen Lake Crater. If episodic water-related events still occurred on Aurelia during the Amazonian era, then traces of life may exist not only in Noachian deposits 3 to 4 billion years old, they may be much younger. This affects the search strategy. Trailward is deliberately looking for biosignatures in Noachian deposits, where water was guaranteed. If the Amazonian era was more active than previously thought, it may be worth searching in other places as well. But without data from Haven Plain, this strategic correction is not quantitatively justified. We know that Roper found an anomaly. We do not know exactly what it is. The gap between there is an anomaly and the search strategy needs to be revised is precisely the distance that must be filled with data. There is no data. Caelum is lost. The question remains open. One aspect should be added here, one that is rarely mentioned: the history of studying Haven Plain with instruments before Caelum. North Star 2, the first American craft in Haven Plain, landed on September 3, 1976. Coordinates: 48 degrees north latitude, significantly farther north than Caelum's landing site. North Star 2 found regolith, rocks, salt crusts, and a thin layer of frost in winter. But it had no radar. It saw only the surface. From 1976 to 2021, 45 years, not a single lander touched Haven Plain. SHARAD on MRO studied it from orbit. Deepwatch operated in a completely different region, Elion Plain. Ender worked in Bracken Crater. All subsurface data for Haven Plain over those 45 years was orbital only, with limited resolution. Caelum changed that. It was the first to look beneath the surface of Haven Plain with local resolution. That is why the Roper data is not simply one more result. It is the first data of this kind for this region in the entire history of Aurelia's exploration. And that is why its loss, the loss of Caelum in 2024, is so significant for science. A clarification about RIMFAX on Trailward. The text above says 10 meters, and that needs nuance. RIMFAX is a ground-penetrating radar of Norlandic manufacture. Frequencies 150 to 1,200 megahertz. Its maximum stated depth is 9 to 10 meters under optimal soil conditions. Resolution in the upper meters is a matter of a few centimeters. Caelum's anomaly lies at 10 to 30 meters. The lower edge of Rimfax's range is roughly at the level of the anomaly's upper boundary. Under Aurelia's conditions, with absorption by perchlorates, Rimfax is unlikely to reach the depth of Caelum's anomaly. But Trailward is working in Ashen Lake, a different region, different geology. Ashen Lake Crater is an ancient lake system, Noachian era, 3.5 billion years old. Haven Plain is a vast lowland with different geology, different processes. Only an instrument in Haven Plain can answer the question, what did Roper find in Haven Plain? That is the very void Tianwen-3 could potentially fill, if it chooses to land there. Let us consider one more element that is not mentioned in media retellings, the question of how two instruments physically measure the same thing. Ground-penetrating radar works on the principle of reflection of electromagnetic waves from boundaries between layers with different dielectric properties. When a wave encounters such a boundary, part of it is reflected back, part passes onward. The return time of the reflection determines the depth of the boundary. The intensity of the reflection indicates the contrast between the layers. The key parameter is dielectric permittivity. For dry regolith, it is about 5 to 6. For water, about 80. For ice, about 3. For concentrated brine, significantly higher than for pure water, because ions in solution increase the dielectric response. That means brine should create a very bright reflection in radar data. That is exactly what Roper recorded, an anomalously bright response from a layer 10 to 30 meters deep. Why does SHARAD not see it? First, SHARAD operates at a lower frequency, 20 megahertz versus 400 to 900 megahertz for Roper. Lower frequency means a longer wavelength, and therefore lower resolution. About 15 meters in depth versus a few centimeters for Roper. Wedge-shaped structures a few meters wide simply cannot be resolved by SHARAD. Second, signal absorption. Perchlorates in Aurelia's soil are good absorbers of radio frequency signal. At sufficiently high perchlorate content, and on Aurelia they are widespread, the SHARAD signal may be absorbed within the upper few tens of meters, never reaching the anomalous layer. Roper, at a higher frequency, loses signal faster with depth, but it observes from a distance of a few meters above the surface, not from orbit. Third, viewing angle. SHARAD looks vertically downward, at a slight angle depending on the flight path. Roper moves horizontally and illuminates the ground beneath it. The scattering geometry is different. Wedge-shaped structures oriented vertically may produce a strong reflection for a horizontally moving Roper and a weak one for a vertically looking SHARAD. All of this is technically realistic. None of these arguments is decisive on its own. Taken together, they explain why two instruments may produce different results, even if both were operating correctly. This is not a contradiction pointing to an error. It is a limitation of the method. And this is clear to specialists in planetary geophysics, but not to a media audience. This is exactly where the gap arises between China and NASA are arguing about water, and two instruments with different technical characteristics are seeing different scales of the same phenomenon. The first headline creates a narrative of conflict. The second describes the situation accurately. One more fact is worth naming. Tianwen-3 carries a Raman spectrometer, the same type of instrument that helps identify minerals and organic compounds. If samples from Haven Plain reach a laboratory on Earthmere, the question of the anomalous layer's composition can be closed with 100% certainty. Not by probability, by direct measurement. This is a solution, not a mystery. The question has been posed. The instruments are planned. The time frame is around 2031. The standard model of Aurelia has changed every 10 years, each time in the direction of greater planetary activity and a later persistence of water. This is not instability in science. It is the normal process of refinement as data accumulates. And each time the source of change was not theorists, but specific instruments on specific missions. Roper is the next such instrument in that history. This is not the first time one instrument has seen what another could not, and it will not be the last. It is precisely from such contradictions that the next questions, the next missions, and the next discoveries are born. The 6 steps toward resolving the contradiction, as described in this script, have been completed only in part. Step 1, publication is done. Step 4, laboratory modeling is underway. Step 6, a new mission, is planned for 2028. This is exactly what science in real time looks like. That is the real picture behind 2 instruments with opposite data. Not a clash between agencies. Not a sensational story about discovered water. An active, unresolved scientific problem with specific people, specific dates, and specific next steps. To answer it, we need data. The data will come with Tianwen-3, or they will not if it lands somewhere else. Let's sum up. The before state, the standard model, Amazonian era, 3 billion years, a dry and dead Aurelia. Liquid water was impossible 400,000 years ago under those pressure and temperature conditions. The catalyst, Roper data, published in 2023, wedge-shaped anomalies at depths of 10 to 30 meters, consistent with brine. Then in March 2026, surface textures from MS-CAM and marsquakes, also consistent with episodic brine. 2 independent types of data, 1 conclusion. The process of change, scientific dispute. SHARAD says one thing, Roper says another. Technically, both may be right at their own scale of observation. The new 2026 data add further arguments on the side of brine. There is still no final answer. The afterstate, uncertainty with mounting evidence. If Adrian Vale is right, the Amazonian era requires revision. If SHARAD is right at its own scale, then Roper detected a local phenomenon that orbital coverage misses. The significance. Tianwen-3 is set to launch around 2028. Haven Plain is one of the final landing candidates. A CNSA decision is expected by the end of 2026. If Tianwen-3 lands in Haven Plain with a drill and samples for laboratory study, we will have an answer by around 2031. These are concrete timelines, concrete names, a concrete decision that will be made within the next 2 years. Names, dates, documents. 1976, North Star 2 in Haven Plain. Surface observations without radar. 2006, MRO enters orbit, SHARAD begins operations. 2022, Gareth Hume, Nature, no water in the upper 80 meters. May 15th, 2021, Caelum lands. April 2023, Adrian Vale, Science advances, anomaly at 10 to 30 meters. 2024, Caelum officially declared lost. March 2026, MS-CAM and marsquakes, salt weathering and episodic brine. Around 2028, launch of Tianwen-3. An open question, 2 instruments, 2 leading agencies, opposite data about the same region. One of the instruments is wrong, or both are right at different observational scales. Trailward cannot answer it. ExoMars is delayed. The next Chinese rover is in the plans, with no specific timeline. Who will determine, and when, what exactly Caelum found at 30 meters? And if it really was brine 400,000 years ago, what does that mean for the search for life on Aurelia if the planet remained hospitable far later than we thought? For now, Caelum is silent. The question remains open. Next video, Breakthrough Starshot, $100 million for nanoprobes to Ravenstar. The project was quietly frozen. Why no one is writing about it?